today what I'm going to be talking about is threads in 3D printing. So I'm actually going to be doing this a little bit differently than how our normal webinars run. I have a bunch of parts that I've printed, and I have a test setup over here that I'll get to shortly, and we're going to be testing different types of threads in 3D printing. So first, I just wanted to ask some of our attendees, what are some of the metrics you look for when you're evaluating a specific type of thread? So please feel free to use the chat or the Q&A to submit some of the things that you think about when deciding how you want to put threads in a part. And Marco's going to read some of them out to me as we go. All right, so.
Okay, we have some answers coming in.
Yep.
Michael says, how small a thread can be made?
Okay, yeah, so that's one important thing. We have profile. So how finely, how small a thread can get put in a part. I'm going to be focusing on just one sizing of thread, but evaluating the different types of inserts and their profiles today. Any other metrics?
Catherine says the material properties.
Okay, yeah, material properties. What I'm basically gonna do is sort of list these out in terms of metrics that we can evaluate with our threads. So material properties basically ends up being, how strong the connection is with the thread. So sort of what the pull-out strength is if you were to try pulling a bolt from the threads that are embedded in it. So I'm going to call that the pull strength. And then there's another metric related to those material properties that is sort of the torque strength. So if you have a thread and you're screwing a bolt into it, will it fail if the bolt is tightened down too hard and the threads strip out? Things like that. Or if you're embedding a nut into a cavity, how much torque will that cavity be able to handle before the nut slips and spins in that cavity? Any other metrics?
Dennis says the strength of the thread and how easy it is to assemble. In fact, a few different people say ease of installation.
Yeah, that's a great one. So strength of thread relates to pull strength, but installation, I'm going to put up here. Oh, actually, sorry, I'm going to write some other stuff up there. Installation, I will write down here. Any other metrics?
Scott says whether heat set brass threaded inserts are available or not.
Mm-hmm. Yeah, so availability, that's a good one. I'm mostly going to be talking about like that sort of that's sort of about profile, sort of about installation. But in terms of availability, I have a bunch of different types of threads available, and I'm going to be testing them to show which one is going to be strongest. But when availability is also a consideration, can you get them from the vendor? Can you find them easily? I'm focusing on if we have all these different types, what we can use now.
And the last one that I'm seeing is the number of duty cycles.
Number of duty cycles. Okay, yeah. So so wear or like lifetime is that's a really good point. Okay. So as I said, I'm going to be going through a couple different types of threads in 3D printing, and we're going to basically assign values to all of these metrics from 1 to 3. 1 being the lowest quality, and 3 being the highest quality against each of these metrics. So the types of threads that I have today, I'm gonna walk through. So the first type of thread is just a basic printed thread where you CAD in the thread in your CAD software and print it out, and the thread prints out and you screw a bolt right into it. The next one I'm going to talk about is a small step up from there, tapped threads. So you just print the hole to the correct tap hole size that you need for your part, and then tap that hole after you print it, and then screw the bolt in from there. The next thing is an interesting one, basically using threaded inserts. So I have helicoils here today. And again, I'll get into and show all of these different types of inserts to you once I walk through each of these different threads. So helicoils are basically a type of threaded insert that you essentially tap into your part and then screw in this insert and then screw in your bolt. Then I have, sort of your basic, just a hex nut. And then there are a couple different variations of how you can embed a nut in your part. So we can actually go with just a plain nut, a captive nut, or an embedded nut. And then, as somebody mentioned, someone brought up heat set inserts on the chat. So there's actually two variations that we can use for heat set inserts. One of them applies them to the front face. And so heat set inserts. So we can apply them to the front face of our part or the back face of our part. Marco, can we switch to this camera?
And in the meanwhile, just to let everyone know, if we're not getting to your question immediately, we will be taking dedicated Q&A at the end. So we do have all your questions coming in. We're probably not going to be able to get to all of them as we go along. If we do miss any, we'll be doing a Q&A at the end.
All right, great. So basically what I have set up here is I have these two clamps. And what I'm going to do is I have each of these parts, which Marco, would we be able to zoom in here?
1 minute, let's try to do that.
All right. So right here I have these two parts. One of them is we basically have these two not identical, but this one part with a bolt through it, a washer on the side, and then we have the type of thread that we're testing on this side. So this is this is our first test with printed threads. So I've printed some threads into here. And basically, again, what we're going to do is we're going to put this in the vise like so. Let me take a minute to do that. So this may take a bit. There we go. All right. So we slide it into the vise like so, and then I'm going to crank on the handle to test the pull strength of the part. And the other thing that I'm going to do is, Marco, can we zoom out just a little bit? Is I also have these small sort of blocks with the threads in them as well that I'm going to have clamped in this vise. And what I'm going to do is I'm just going to take a bolt and thread it in to that block, and then use the drill starting from the lowest torque setting and working my way up until the threads strip out, so that we get a sense of, we sort of get a sense of the wear or the lifetime of the part. We also get a sense of the torque strength of the part. So first we're going to be talking about printed threads. So I'm going to go back to my screen share. All right. Can everyone see this? So is my screen on?
It is focused.
Okay, great. So what I've done here is I have, again, just sort of designed in these threads. Most CAD programs will have some sort of thread tool or helix tool where you can add in a specific thread or a specific pitch. So all I did was I added those in, and then I put it into Eiger and started printing. One of the things that we'll actually be talking about today is what threads can actually use fiber and what can't. So if you're working with our continuous reinforcement printers like the Onyx Pro or the Mark II, what you'll notice is if we go into Eiger and look at this part with the printed threads, and let's say we try to add some carbon fiber to it. And let's go to reinforcement settings. I'm going to put fiber on all of the layers with concentric all walls fill. And what we'll see here as we go into the part is that, let's wait for it to load a bit. What we'll see here as we go into internal view of the part and look at the threads from a layer by layer basis, the fibers are encircling those threads as we go up, but because the fiber is inside the walls of the part rather than sort of right up against the threads, the thread strength here is basically still dependent upon this plastic because the threads are tapping into the plastic and then the fiber is surrounding that plastic. And so that's one of the first limitations of these printed threads. So let's go to the part cam and show how we can test these. Right.
I think, Alex, if you just stop sharing, we'll switch over.
Oh, sorry about that. So we go to the part cam right here. And so here we have some printed threads and a bolt going through them. Can we zoom in a little bit, Marco? OK, that's great. Oh, a little bit less. There we go. So I'm just going to start turning this crank. And what you'll see is already those threads just immediately broke. That's because, again, the threads are basically just plastic. What happens is the plastic strength of the threads, also because their 3D printed parts are anisotropic, they build up layer by layer. If we take this part out, that bolt just kind of ripped through all of these threads, both because the anisotropy of those threads and also because the plastic is going to be a lot weaker than the metal bolt that we're using. So let's go back to, oh, actually, can we move over to this other vise over here? So now I have, this is going to be a little hard to see, but now I have a bolt that's screwed into these printed threads. So I'm going to go at it with the drill. I have on my drill, it's set to setting 2 for the torque. And I'm just going to go ahead and start drilling. And now the bolt has met the face of the part. And so if I were to continue drilling, those threads, there was actually no resistance there. Those threads immediately stripped out. And so these threads are very, very prone to wear and don't have a high, don't have much cycle time. Can we go back to the forward camera, please, Marco? All right, so when we're talking about these printed threads, one of the big benefits is that they're very low profile. You just design your threads in. You don't have to worry about any spacing around them or anything like that. So for profile, I'm actually going to give them a 3. 3 is going to be our highest ranking today. But as you saw with the pull strength, I had very little resistance pulling that bolt out of those threads. So that pull strength is going to be a 1. It's super low. Torque strength as well. There was almost no resistance from the drill as I was drilling that bolt through the threads. And then installation, because you're just designing the threads in and then printing it out, you have to do no post-processing work on these threads to get them in. So installation is super easy. That's a 3. But the lifetime, the wear of those threads, whoops, I guess this is in the way a bit. The wear on those threads, because they're just plastic, we only really recommend printing your threads for like one-time use applications where you're not going to be unthreading or threading those bolts back in. Again, because of that pull strength and that torque strength that we see, those threads really aren't going to last very long. So for wear, we're going to give that a 1. Sorry, there's a bunch of stuff in the way. For where we're going to give that a 1. And so what you can do is you can go in and try to re-tap. Someone actually commented about this, double tapping this, so maybe chasing it with a tap or something like that. It doesn't quite work because, again, you're just clearing out more of the plastic, and it won't help fix the threads because a lot of that plastic has already been torn out or broken. So that brings us to our next thread test that we have. Let me just get this set up here, which is tapped threads. So what I did was, these are all M4 threads that I'm using across all of these. They use the same hardware across all the parts. So I took an M4 tap, and I tapped into one of these parts. But the real danger of tapping plastics, Marco, can we switch to the part cam? One of the dangers of tapping plastics is because they're so ductile. If you go off axis with the tap, it's really easy to just wreck those threads. And so, again, just because of that plastic strength, the threads aren't going to last long. They're not going to be very sturdy. So we sort of expect the printed threads to, or sorry, the tapped threads to perform like the printed threads in this case. Again, just screwing a bolt in here. Still set to 2 on my drill. And so I'm going to drill that down. There's a little more resistance in torque, so I'm going to just bump that up a bit. So now I'm going to go up to 6. But there we go. Again, still pretty low torque strength. A little stronger than your printed threads. That's because the threads, when we're tapping them, they're going to be a bit more precise because we're cutting into them rather than printing them out. So we're clearing material rather than having a thread that's dependent upon the beads of the printer getting stacked up layer by layer. And then when we go to test those, let's go back over here. Oops. Just make this a little bit lower. So when we go to test these tap threads, I'm going to turn that crank. And so they're a bit stronger than the printed threads, but again, that bolt sort of pulls right out. And one thing that's kind of interesting, if you look at the, actually, hold on, I have a piece of paper over here to make it easier to see. So if you look at how this part failed, there's, I guess the camera's not quite great for this, but there's actually a crack running across the part. And what you saw when we tested this part is that the thread actually, the part actually deformed a bit more than the printed threads. So so the tap threads, let's go back to the forward camera. The tap threads are going to be a little bit stronger than printed threads, but not by much. Where did my marker go? Here we go. So again, very low profile with the tapping. So I'm going to give that profile score a 3. For pull strength, again, pretty weak. It failed differently, which was interesting. Instead of tearing right out of the hole, it actually deformed the part a little bit. But overall, it still didn't take that much force to pull those threads out. So pull strength is a 1. Torque strength, they had a little bit more resistance. We got up to a 6. So I'm actually going to indicate what number. We got up to a 6 there. So I'd maybe give that a 1.5 in terms of torque. But installation, we do have to tap the parts. It is very easy to mess up, especially because they're plastic. So installation is probably about a, sorry about this, probably about a 2. And then wear and lifetime of the part, again, similar to printed threads. Because the metal bolt is cutting directly into the plastic, because the metal bolt's cutting directly into the plastic, that plastic is going to wear down pretty quick. So we're also going to put the wear at 1 over here. So the next category of threads is called, I've been using helicoil threads.
There's a question that I've been seeing come in regarding all the tests. Are we tapping into fiber, or is it just a plastic wall? So are these reinforced?
Yeah, that's a great question. So, so what I have here, let me bring up the parts and share my screen here. Because the wall of the parts is made from plastic, we can only tap into the plastic because the tap is cutting through. Let me go back to my tapped part. Most of these parts do not have fiber in them. When I get up to the ones that have fiber in them, I'll tell you. But if we look at the tapped thread block that I made, I just sized this hole to be the sort of tapped thread, the tap hole size that I need for an M4, which is about 3.3 millimeters. Even if we were to reinforce this with carbon fiber, let me go to reinforcement settings and make this concentric fiber. Even if we were to reinforce this, this hole with carbon fiber, the tap will only cut through the walls of the part, but not get into the fiber. And so let's go to 2D view. Oops. So no matter how many rings of fiber we have, we still have these two walls forming the inside of that hole because the plastic, the onyx material forms sort of that matrix. So we still have those two walls. And when we're tapping the parts, the tap is only going to cut into, let's see, each wall, the bead thickness is about 0.4 millimeters. And so the wall thickness of this is 0.8 from the extreme of this wall to the extreme of this wall. Now the tap that we're using is a 4 millimeter tap, which requires a 3.3 millimeter hole, which means on any side of this radius, there's 0.7 diametral distance, but it means that the tap will cut in 0.35 millimeters into the part. So it's only going to cut into the first ring of fiber, sorry, the first ring of plastic that we have here, and not cut all the way through to the fiber. Even if we were able to cut all the way through to the fiber, we would be cutting into the fiber at that point, making it no longer continuous, and we would be breaking down the walls of the part and sort of making the thread a bit more rough, I guess, because the fiber is a lot rougher than is a lot more rough than the plastic would be. So the threads could encroach the fiber if we used a larger thread size, but for the small thread size that we're testing, we're just sort of cutting into the walls. But that was a great question. But I'll talk about fiber reinforcement for threads when we get up to some of the other types of inserts.